Alright, so we have the example 2 to solve this type of exact equation, and that is e to the power 2y minus y into cos of xy. Here angle is x into y into dx plus 2x into e to the power 2y minus x into cos of xy here is angle, plus 2 into y, and bracket gets common, into dy equals to 0. So this is kind of quite lengthy equation. So what we have to do, again, same that procedure. First of all, identify what is m. So what is m? M is e to the power 2y minus y cos of xy, right? And what is n? N is 2 into x e to the power 2y minus x into cos of xy plus 2y. So we have to check that whether this satisfies the exactness criteria or not. So partial m by partial y equals to partial n by, should be equal to partial n by partial x. Partial m by partial y. So I am replacing m as e to the power 2y minus cos of xy equals to partial by partial x of n. N has the terms 2x e to the power 2y minus x cos of xy plus 2 into y. So now first term is e to the power 2y, and because it is a linear operator, so we can differentiate it with term by term. And one more thing is, if we have two terms and they are multiplied, so we should apply the product rule for derivatives. Okay, first is e to the power 2y. So what's the derivative? Derivative is the power of that exponent, the derivative of the power or that thing. So its derivative with respect to y is 2, so it becomes 2 e to the power 2y. Its derivative is this. And then in this we use the product rule, because both of these functions contains the y. So the product rule is derivative of the first function and second function remains as it is, plus derivative of the second function and first function remains as it is. So we have no space further. Okay, now again, no, there are two functions, but second function is e to the power 2y. So y is considered as constant here due to partial derivative, so we are only concerned with this x. So 2 is a constant, e to the power 2y is a constant, and partial by partial x of x is derivative 1. And here product of two functions that contains the variable x. So again I am applying the product rule for derivatives is partial by partial x of x, and second function remains as it is, plus derivative of second function, and function first remains as it is, plus 2y. 2y is a constant with respect to x, so its derivative is 0. Now what we have to do, we have to take the derivatives and we solve it. So this is the process of checking the exactness criteria, right? So y has the derivative 1 and it remains cos of xy. Okay, and minus sign due to this, and minus sign due to this in this term is minus, and here cos of xy, angle is theta here is x into y, and x here is a constant, so cos of theta has the derivative minus sign. So cos of theta has the theta here is xy, so what we have to write? Minus sine xy and derivative of theta, derivative of xy. So x is a constant here, so we write it as like this. If it is just like this, cos of 2y, so 2y has the derivative with respect to y is 2, so cos of 2y has the derivative minus 2 into sine of 2y. So simple is like this. Okay, so left hand side is done, and right hand side I am writing here. Acha, 2 e to the power 2y minus x has the derivative 1, and it is left with cos of xy. Okay, simple. Cos is same, is like that, partial by partial x, but here is variable is x, so y is considered as constant. So cos of like 3 here, y is here 3, so cos of 3x has derivative minus sine 1 minus is because of this, and 1 minus is cos has derivative minus sine of xy, and here y is considered as constant, so xy has derivative y. Xy with respect to x as derivative, partial derivative y, and x, okay, x is as it is. Now we arrange it. 2 e to the power 2y minus cos of xy plus x sine of xy, and here y, we are missing this y, so I am also writing this x into y equals to 2 e to the power 2y minus cos of xy plus xy sine of xy. Equal, both sides are equal. 2 e to the power 2y is equal to this, minus cos of xy equals to minus cos of xy, xy into sine of xy equals to xy into sine of xy. So we can say that this equation is exact. To solve this equation, I am using alternative method. So alternative method, we have to start with assume n equals to partial f by partial y, and then integrating this equation with respect to y. Okay, so here n is 2x e to the power 2y minus x cos of xy plus 2y, this is n, and that is equal to partial f by partial y. So when we integrate this with respect to y, partial f by partial y becomes f of xy, and this function is n, this term by term function is n. So oh my god, so integrating term by term, 2x e to the power 2y minus cos xy plus 2y into dy, and one term is missing, that is plus g of x. Okay, so this becomes 2x here is a constant, e to the power 2y has the derivative e to the power 2y divided by 2. In the derivatives, the constants are multiplied, but in the in exponential and trigonometric functions, and in the integrals, constants are divided. Okay, here x is a constant, considered as constant, and cos has integral plus sign. So this is theta, you consider it theta. So plus sign xy, and I told you that the constants are divided in the integral. So here constant is x, so I will write it by x, and 2y 1 into dy, 2y square, sorry, not 1 into dy, 2y square by 2 plus g of x. So solving this, f of xy becomes x e to the power 2y minus sine of xy plus y square plus g of x. So here is equation A, right? Okay, in the next step you have to assume the third step, m equals to partial f by partial x. Now what you have to do, you have to differentiate this equation A with respect to x in simple words. Write m function is this, e to the power 2y minus y cos of y. So I'm writing this m e to the power 2y minus y into cos of xy equals to partial by partial y of equation A, this, and this one is x e to the power 2y minus sine of xy plus y square, sorry, it is partial by partial x plus g of x. So with respect to x it is differentiated, and e to the power 2y is a constant, so it becomes e to the power 2y. And here sine of xy, so if it is differentiated with respect to x, so y is considered as constant, and sine has the derivative plus cos, so that is cos of xy, and multiplied the constant y, and y square has the derivative 0 with respect to x, and g of x has the derivative g dash of x with respect to x. Okay, so I am solving this minus y cos of xy plus g dash of x and e to the power 2y minus cos of xy. So it gets cancelled with this, it gets cancelled with this, and g dash of x is equal to 0. Okay, in the fourth step what we have to do, in the fourth step, I'm writing here, fourth step, integrating this g dash of x with respect to x. G dash of x here is 0. So that becomes g of x, and what's the derivative of integral of 0? Constant c, right? Constant has the derivative 0, 0 has the integral constant. So only I can do here is I just replace g of x equals to, in this equation A, I just replace this g of x as c, and that is the solution, f of x y equals to c. So that's it.